Hello and welcome again. In today's online lecture series, we'll discuss about the special casting methods. This is the third unit of WT of MDU syllabus. So we'll be talking about special casting methods. What are the casting methods we have earlier discussed, and now we'll see what are different casting methods. And now this is the basic, as you know, these are basic concepts of casting. So we have earlier discussed the concept of casting. We have earlier discussed types of patterns, advantages, disadvantages, materials applied, and then we talked about the molds and the molding sand, and then we came to this topic of special casting methods, special casting processes. So we can see this is the basic concept that we have already discussed in detail. This is the molding flask, and in molding flask we have this molding sand, then we have pouring basin, this is screw, the molten metal comes to this place, and this is the core that basically stops the molten metal to come inside this place, and this way a cavity is created. This is the runner, and then this is the vent through which the flue gases pass over. So this is upper part is known as scope, lower part is known as drag. So this is parting line, and these are locating pins that are basically to align the top portion and lower portion. Now we'll talk about the sand casting processes. As we know that molding sand is used to prepare molds. So what are the special methods of casting processes we will be doing in this section, in this today's lecture? We got to know that the sand casting is the casting basically that depends upon the molding, the mold that is made up of sand. So core making, pattern making, mold making, riser, these are the block. This is the block diagram that explains step by step method. This is pattern making, mold making, riser, runner and gate making, melting and pouring, solidification and cooling, removal of sand casting, cleaning and inspection, finish casting. These are the steps that are involved. Raw material is here, raw material comes from here to here. Then sand is this a process of sand utilization. First of all, sand is prepared for making mold. Once mold is made, then mold is made. Then after other parts, that is runner, riser and gate making and vent making, are done by this sand, and then by this application, then pattern is made. Pattern is allowed to pattern is basically duplicate or replica of the part that is to be produced, and this way pattern is involved in mold making. So this was the basic concept we have earlier discussed. Now we are coming to the special casting methods. So first of all, we'll talk about two types of casting methods. One are expandable and there are permanent molds. Permanent molds and expandable molds. Expandable molds are those molds that basically distort at the time of pouring the metal, and there are considerable expansion in the molds. So this is the mold, expandable molding. Whereas permanent molding, they don't have any effect when the molten metal is poured into the cavity. So the molding is two types of molding processes. One are expandable and another is permanent molding. So shell molding is a casting process in which the mold is thin shell of 9 millimeter thick. This is made of sand held together by thermostatic resin binder. Shell molding, in the shell molding we have thin shell of approximately 9 millimeter wall. So shell molding is made up of shells, and metal pattern is heated and placed over a box containing sand mixer with the thermostatic resin. So shell molding has a mold that is basically made up of 9 millimeter wall. Then box is positioned to the previous state, that so that loose uncured practical. So this is the shell molding. You can see a picture, heated pattern. Then this heated pattern, there is sand with riser binder, and then this is inverted. Once this is inverted, the mold is made, and it is actually hollow from inside. When the mold is hollow from inside, it is known as shell molding. That's so shell is made up in the mold rather than solidified molding. So this way we consume less sand mixture, and uh, you can see here, if this is completely filled, this would have taken much more sand, and when this is shell mold is made, so we can see shell is molding sand is used for making shell only, and from inside the mold is hollow. So this way we consume little molding sand, and this is the benefit of shell molding. So shell molding has a shell of a thin layer of wall, thin 9 millimeter, so approx 9 millimeter. So this is called shell molding. So this is complete as similar to molding or casting. This has no effect. Only the difference is that we utilize less molding sand, and you can see the pattern is heated, so obviously this must be of metal, made up of metal, otherwise this would not have been possible to heat this metal. So heat this pattern, so pattern is made up of metal, and this the molding sand is filled in the bottom, and when this pattern is heated, it is reversed down, upside down, so you can see the sand will come down, and when it comes down it will stick, because it is provided with the additives and binders, so that it sticks with the pattern, and then solidification cooling time is given, and after solidification or cooling, this is again inverted, and the molding sand sticks to the pattern, and after that pattern is removed, so this is a mold cavity created. So this is the shell molding. Now come to the process by which the shell molding is done. So this is the process. It is kept in furnace, and after furnace we overturn, then overturning, then you can see this is the shell that is made up of molding sand. So this, rather than being solidified, it is hollow and uses less sand. So this is the benefit of shell molding. At the same time, it has one more. It has disadvantage, that since it is not solidified, it is not as rigid as other shells, as other uh, molds. So this has a little less stiffness or strength as compared to the other molds, solidified molds. So this is the negative point. So these are the parts that are made. Advantages, these are advantages. Good surface finish can also found in shell molding process. Disadvantages, expensive metal pattern is required, and the other one is that it has less strength. The mold has less strength. But applications are gears, valve bodies, bushings, and camshafts, etc. are made by this shell molding process, because it produces good surface finish, and at the same time high accuracy of the product. So machining operation is reduced because of good surface finish, and also can be mechanized for mass production and will be economical too. The disadvantage is that it requires metal pattern that is costly, and hence not suitable for small quantities. So now we have got the application, we have got this process, advantages, disadvantages. We'll come to the second special casting process, that is vacuum molding. In vacuum molding, the mold is made by the application of vacuum. So we will see in this process a sand mold is held together by vacuum pressure and not by the chemical binder. So the vacuum is provided to shell the molding sand, and this way it is called, the term vacuum in this process refers to the making of the mold rather than the casting operation. Casting operation is same as to any other process, but the vacuum molding is in vacuum molding, vacuum is applied to prepare the mold rather than actual casting process. The vacuum is applied to make the mold, and this vacuum basically preserves the intactness or togetherness of the molding sand. So we can see here vacuum. This is the vent holes, vacuum drawn. So we can see this is plastic sheet, this is pattern, and this is the vacuum pump. So then vacuum pump is given, then vacuum pump works. So there are vent holes to draw plastic. So we can see when this is plastic sheet is here. So when there is a initially there is a pressure between when plastic sheet and the pattern, but when vacuum pump is applied, it starts evacuating the air from this place. When this air is displaced, so the plastic sheet will take the shape. The plastic sheet will stick in accordance with the shape of the pattern, and the plastic sheet will take place, will take curve of this pattern. So this way the plastic sheet will stick to this pattern, and then when this sticks to this pattern and the sand is filled over it, and again riser, runner, screw all are placed, and then second plastic sheet, another, this one is first and another is placed above it. So again vacuum pump is applied at this point. So this will again seal, this plastic will seal the whole molding sand, and this way we will have the mold. And once these two are stick together, we in between the molding sand is there. So what we do, we remove the pattern as we are doing in all types of casting, because molding, because pattern is not for the casting, pattern is removed at the time of casting, so that it evacuates, it makes place for melting molten metal. So pattern is removed before casting, so you can see at this place. And so we remove the pattern along with this system, along with this mechanism that we have applied for creating vacuum. So this way we can see the impression of the pattern is on the plastic film or plastic sheet, and this way we have got the cavity created as per the pattern or the replica of the part. So we can see here there are two types. One is scope, another is drag. So again the drag is prepared with applying the same methodology, same technique. So this way we produce two parts, scope and drag. This is scope and this is drag. And now these two are joined together to make a complete part, to make a complete mold, and the molten metal is poured and vacuum drawn. This is for sealing the mold all around, all over by thin plastic sheets or films. So this way we have got better surface finish, better accuracy, and at the same time good strength also. Precision is achieved there. So this is the basic concept of vacuum molding, and you can see advantages. No binders are used, and hence sand is readily recovered in vacuum molding. Mechanical priming is not required. No water is mixed with the sand. Moisture related defects are absent, and disadvantage relatively slow and not readily adaptable for mechanization. This is the process. This process is quite time taking, so cannot be taken with the cannot be applied for automation. So this was the advantages and disadvantages of vacuum forming. Now come to the expanded polystyrene process. In this process, we see that the the mold expands slightly. So we can see this is similar to normal casting. Then we make, first of all we make a pattern. Then pattern is uh, polystyrene pattern is coated with the refractory compound. So you can see this is the polystyrene pattern. coated with refractory compound. We apply a refractory material that is basically uh, heat resistant material, and that is applied, spraying refractory compound over this pattern, and then this pattern is placed in molding shell or molding box. We ram the sand and around the pattern, and once it is uh, pattern is placed in the mold box and packed with sand around it, molten metal is poured into the portion of pattern. So this is basically the pattern, and this pattern allows the molten metal to be taken inside. So this process, a mold of sand packed around a polystyrene foam pattern is used. This pattern will vaporize when the molten metal is poured into the mold. So at the elevated temperature, high temperature, this mold, this pattern that is made up of polystyrene is dried up or is melts and comes out with the in the form of liquid, so or vapors. So this is the process. Polystyrene foam pattern is used. The pattern will vaporize when the molten metal is poured into the mold. So this was the process of expanded polystyrene process, in which material that is easily convertible, that has very low melting temperature, and that can be easily converted into vapors. So this way, rather than removing the pattern is converted into the fumes or vapors, and this way the vapors are extracted, the vapors are ejected from the pattern, from the mold, and so there is no need of removing the pattern. So this has, it is also called lost foam process, lost pattern process, evaporative foam process, and basically it is known as expanded polystyrene process. But the common names are lost foam process and lost pattern process, because pattern is lost and pattern is not found in the molding. So pattern is reduced, pattern is lost into the vapors, so also called pattern, lost pattern foam process. Another type of casting we'll study is similar to loss pattern process or expandable pattern process. In the other type is investment casting. In investment casting, the pattern is also not recovered and completely goes down, but in the form of liquid. In the loss foam process, the pattern is converted into the foams or fumes, and that is ejected by the mold at elevated temperature. But in case of investment casting, we have got the pattern made up of wax, and this wax at elevated temperature melts, and this molten wax comes out. We are given a drain, we are given a cavity, capillary by which this molten wax comes out. So this is also a type of casting in which pattern is not recovered and pattern is lost. So in last time we have last foam process, we have seen the pattern is converted into foams or fumes, and that is ejected by the system. But in this case, the pattern is converted into the mm, liquid, and this liquid is taken out. So in investment casting, the pattern is made up of wax, because wax has lowest melting temperature and it is easily melts, and it produces good surface finish, it has good flowability. Because of these reasons, wax is used as pattern material. So we can see this is the wax pattern. This is the sprue, wax sprue, through which this is a pouring basin. The molten metal is metal poured through this pouring basin, and then this molten metal will come into this wax in this place, this place, this place, this place. These are the wax patterns. These are the actual uh, duplicate of the actual product, replica of the actual casting that is to be made. And this way, when the molten metal at elevated temperature, high temperature, enters into the pouring basin, it starts melting the wax within minutes, and the wax is molten. And this way, this is the solidified wax is turned into liquid, and we give a drain through which the molten metal comes out. As you can see, when the molten metal is produced, molten metal is poured. So the wax are first made, several patterns can be attached. So the molten wax is taken out, is given a cavity, and this way molten wax will create a cavity and will be coming out of the mold and creating cavity for the molten metal, and the molten metal will replace the wax. Once it replaces, it will be given solidification time, and after cooling and solidification, the mold is opened and the part is taken out. So in this process, wax pattern is also lost and pattern is not recovered. So this is the process of lost wax molding or casting. You one thing I told, two or three things I told at the starting of this process, that this wax is quite has quite enough flowability, so we can see that wax flows out smoothly. Number one. Number two, the wax has very good surface finish, very accurate. So accurate parts or accurate components can be casted through which, and with high surface finish. So mm, these are the advantages of wax pattern or lost pattern process. But at the same time, it has disadvantage that complex and intricate parts can't be casted through complex and intricate parts can be casted. But another problem is with this method, the problem is with this method that it cannot be uh, you cannot cast complex you cannot cast big parts, you cannot make big parts of by lost wax process. This is the disadvantage of this lost wax process. For applications, steel, stainless steel, high temperature alloy, etc. can be casted. So this was another process in which we don't recover the pattern. Now plaster mold and ceramic mold casting. So these are another method in which plaster mold, plaster of Paris, and ceramic molds are made, and you can see these are permanent mold processes. So this was about the special casting methods that we have discussed today, and a few remaining we'll discuss in our next lecture.